We're looking at Chapter 3, Section 1 on parallel, perpendicular, skew, and a couple different types of pairs of angles we're going to be looking at today. To start off with, we're going to look at this three-dimensional cube here. Parallel and perpendicular is what we're going to be concentrating on. So if I pick a line, let's say I want to talk about line AB. Line segment AB. Line segment AB is going to be parallel to a couple different lines in this figure. If you recall, parallel means that the two line segments will never intersect, and essentially they're going in the same direction. They lie in the same plane, is what we say. So AB is going to be parallel to, well, if I look at the line segment FH is going to be parallel to line segment AB. And when I denote, when I write that AB is parallel to FH, I'm going to use this symbol here, two vertical lines. And what that says is line segment AB is parallel to line segment FH. There are a couple other line segments that AB is parallel to. AB ends up also being parallel to GC. So GC is going to be parallel to AB. And there's one more, ED ends up also being parallel to AB. Even though they don't necessarily look like they're in the same plane, if we drew a plane between AB and ED kind of at an angle, we could do that. It's not there, but if you use your imagination, you could put a plane in there. And it's hard to draw, so I'm not even going to try. But AB and ED do end up being parallel. And one way to remember that is they're going in the same direction, and they both they're going in the same direction, and they never intersect. So AB ends up being parallel to AB ends up being parallel to ED. There we go. Perpendicular. Perpendicular means that the two lines intersect at a 90-degree angle. So if I look, one easy one to see might be line segment BC and line segment CG. If I look, they make a 90-degree angle there. So BC ends up being perpendicular to GC. And the symbol we're going to use to denote perpendicular is an upside down capital T. BC is perpendicular to GC. Well, BC is perpendicular to a couple different ones. BC ends up being perpendicular to, a little bit better, ends up being perpendicular to BA. There's my 90 degrees there. So BA ends up being perpendicular to BC. Another one is going to be that BC will be perpendicular to DC. And I'm sorry, I just realized I have BC is perpendicular to BC. In that second one, that should be BA. I apologize about that. There we go, BA. One thing to notice is that all of these share a common letter. The first one, C and C. Second one, B and B. To intersect, they have to have at least one letter in common, C and C. And so the last one that are perpendicular to BC here, the last other line segment, is that BC is going to be perpendicular to another one with B. Because we've already got two using C. We only have one with B in common. So you can use that as kind of a helpful hint for you. So the last one that we're going to be looking at here is that BC is going to be perpendicular to BH. And so looking in 3 dimensions is going to be a skill that you need to practice with, that you need to look at a lot of examples and try and pick out lines that are perpendicular and parallel. So those are those two. Next one we're going to be talking about, this is kind of a new one, are skew lines. Skew lines you really only see in 3 dimensions. The other ones you can kind of see in 2 dimensions, but skew is a little bit different. Skew lines are 2 lines that never intersect and are not in the same plane. So parallel was 2 lines that never intersect and are in the same plane. Skew are that they never intersect each other, but they are not in the same plane. Remember that not in the same plane, in layman's terms, so to speak, and in terms of what you should remember, is that they're not in the same direction. So if I look here, I'm going to use AB as an example again. So AB, if I look, FH is going in the same direction as AB. Even though they never intersect, it's still going in the same direction. So those are not skew. ED, again, going in the same direction. So that is not going to be skew. However, if you look at, and I'm going to highlight them here just to kind of help a little bit. If you look at AB, and if you look at, say, HD, those 2 lines will never intersect each other. They'll never touch, and they're not going in the same direction. One is going vertical, one is going horizontal. Those 2 lines are skew. And there's no nice symbol for skew. I'm just going to put and. AB and HD are skew lines. Another one that would work is FE is also skew because it's going in a different direction and it will never intersect AB. There are quite a few of them. DC, EG are also ones that are skew with AB, and so there are a number of them. But you're looking for, again, lines that do not go in the same direction and never intersect. An easy way to tell that they don't intersect is they don't have a letter in common. AB and HD don't have a letter in common. AB and FE don't have a letter in common. So again, take some practice, look at a lot of different examples to try and determine which lines are skew. So moving on, another word that we're going to be looking at here are lines that work with parallel and transversals. So a transversal, this is one that we're going to be using for a couple different sections here. Transversal is one line that intersects 2 other lines. Seems very basic, and it is, but we're going to be now working with these transversals in a minute here. One thing to remember is that the 2 lines do not have to be parallel. However, most of the time we're going to be dealing with parallel lines. So a transversal, one line that intersects 2 other lines. This picture I've got here, we've got a transversal, we've got 2 lines that it intersects, and when we have that transversal, we've created 8 different angles. So I've got them numbered here, 1, 2, 3, 4, 5, 6, 7, 8. You can number them however you want. And when we do that, we're also creating different types of angles. We've got corresponding angles, alternate interior angles, alternate exterior angles, and what our book calls same side interior angles. Other books may call it consecutive interior angles, but I'm going to use the same side interior angles term. So start with corresponding angles. Corresponding angles correspond. There's really no nice definition for any of these. They're just pictures and examples. So if I look at angle 1 is going to correspond with angle 5. And one way to tell that they correspond is that if you look at angle 1, it's got a line below it and a line to the right of it. Angle 5 is the only other angle with a line below it and a line to the right of it. So angle 1 and angle 5 are going to be corresponding angles. So I'll write that down here, angle 1 and angle 5. We could also look at, say, angle 2 and angle 6. Those are corresponding angles. They have a line below, line to the left, line below, line to the left. And so those angles correspond. So I'm going to put down angle 2 and angle 6. I'm not going to write all of them down. You could put 4 and 8. You could also put angle 3 and angle 7 are corresponding angles. And that's just what it means to be corresponding. In most of the books that I've ever looked at, they just give you a picture. So that's what it means to be corresponding. Next, what we're going to look at are alternate interior angles. Now, alternate interior angles, the first thing you want to look at is that word interior. Interior, in this case, is just going to mean that they're in between those two lines. So interior, inside, in between, however you want to look at it. So 3, 4, 5, and 6 are our interior angles that we're going to be dealing with. When they're alternate, you want to look at angles that are on either side of the transversal. So like 3 and 4 are on either sides of the transversal, 5 and 6 are on either sides of the transversal, and top and bottom. So alternate interior angles are in between the two lines, on opposite sides of that transversal, and top and bottom. So like angle 3 here, the alternate interior angle with angle 3 is going to be angle 6. Top and bottom, alternate sides of that transversal, and on the interior. So angle 3 and angle 6. The other set of alternate interior angles is going to be angle 4 and angle 5. Angle 5. Alternate exterior, same idea, although instead of the interior, we're going to be looking at the exterior, the outside of those two parallel lines. So my exterior angles in this case are going to be angles 1, 2, 7, and 8. Those are my exterior angles. To be alternate exterior, that's been alternating sides of that transversal and top and bottom. So if I look at angle 2, the alternate exterior angle with angle 2 is going to be angle 7. They're on alternate sides of the transversal. They're on the exterior, and they're on top and bottom. Angle 2 and angle 7. The other angles obviously would be angle 1 and angle 8. That's the other pair of alternate exterior angles. Angle 1 and angle 8. The last set we're going to look at here, same side interior angles or consecutive interior angles, depending on your book. Excuse me. Now, these are very self-explanatory. They're on the same side of the transversal, and they're interior. So 3 and 5 are on the same side of the transversal, and they are both interior. So angle 3 and angle 5. The other set, 4 and 6, are on the same side of the transversal, and they both are interior angles. And those are our 4 types of angles that we're going to be looking at when we have a transversal and 2 lines. Again, typically those 2 lines will be parallel, but not always. Corresponding angles look the same, so to speak. A line below, a line to the right, line above, line to the left. Alternate interior angles, interior and on alternating sides of that transversal. Alternate exterior, alternating sides of the transversal and on the exterior of those 2 lines. Same side interior, in between the 2 lines and on the same side of that transversal. Okay, good luck.